Welcome back. We're going to do the examples now that go with the topic 1 notes for solving equations. And so if you are confident on doing some of these problems, I'm going to encourage you that it is a great idea for you to even pause the video, try an example on your own paper, and then restart the video and see how you did. And so I encourage you to do that if you're feeling like you do know how to solve this problem. So when solving an equation, I'm going to go through the steps. You might remember that our steps were first to use the distributive property, and second to combine like terms. And I don't actually have either of those situations in example 1. So there's nothing for me to distribute, so I'm going to skip step 1. And there are no like terms, so I'm going to go ahead and skip step 2. Step 3 says to cancel one set of variables if you have variables on both sides. And I don't have that either. So I'm going to go ahead and move all the way to step 4, which is to cancel or eliminate any addition or subtraction. And so what I'm talking about with addition and subtraction is something being added to the variable. So right here where I have this plus 8 being added to my 5x term, I'm going to go ahead and eliminate the variable. My goal here is to isolate x. So I'm just going to subtract 8 from both sides. I'm undoing the equation. This order here is actually kind of reverse order from order of operations, especially at the very end of our steps. All right, so 73 take away 8 is 65. And then I'm going to divide. This particular problem gives us a really nice whole number answer. That is not always going to happen. In fact, often you will get answers that are not whole numbers, and you can go ahead and leave them as fractions if you prefer. If you do leave them as a fraction, they must be reduced. You are also welcome to convert them to a decimal, and your teacher usually will give you rounding rules on an assessment, but 2 decimal places is a pretty good rule of thumb if you want to write something as a decimal. All right, number 2, there is nothing with a distributive property, so I cannot do step 1. So that one's done. Combining like terms, however, I do have like terms that are on the same side of the equal sign. So this negative 4x, the positive 4x and the negative 7x, I can combine those. And then the 20, the positive 20 and the positive 42 could be combined. Notice I'm not going to combine the 90. It's on the right side of the equal sign. It cannot be combined unless they're on the same side of the equal sign. So if I combine these and rewrite them, I usually put the variable term first. So I'm going to combine the 4x minus 7x. 4 minus 7 is negative 3, and that tells me how many x's I have. And then 20 and 42 is positive 62. I'm going to put a plus sign in front of it because it's positive. And I do not have any variables that are on both sides, so I'm going to skip that step. And now I'm going to cancel addition and subtraction, which is the next step. So I will subtract 62 from both sides and rewrite this. Equation is negative 3x equals equals 28. Each time after you do a step, you want to rewrite your equation, and your equation usually gets simpler after each step. So the last step after you cancel addition and subtraction is to cancel multiplication or division. And so this particular one, sometimes people look at it and think it's subtraction because they think, oh, I'm taking away 3 from x. But we really want to look and see what's happening between the 3 and the x. And since they're right next to each other, this is multiplication. The inverse operation of multiplying is dividing. So I want to undo the equation with the inverse or opposite operation. So when I rewrite this equation from here, 3 doesn't go evenly into 28. So I'm going to actually write my answer as a fraction because one term is positive and one is negative. When I divide, I keep that negative. And I'm going to go ahead and just check to see if these have any factors in common that could reduce out, but they don't. Alternatively, you could choose to write this as a decimal. This is, let's see, negative 9 1/3, negative 9.3 repeating. I'm going to just write the repeating bar instead of writing 2 decimal places. It's actually considered a little bit more accurate that way. All right, example 3. I'm going to start with the distributive property because the 6 is right outside those parentheses. And since it's right next to it, it means multiplication, and that's when you distribute. So when I rewrite this, I will have 30y minus 24 is equal to 23. Step 2 is to combine like terms, and I don't have any like terms. So step 3 is the next one to consider. If I have variables on both sides, I would cancel them. Cancel one set of them. I don't have that. So I'm going to go to step 4, which is to isolate our variable by doing inverse operations with addition and subtraction. So when I rewrite this, 30y is equal to 47. And the last step would be to go ahead and cancel that 30. The 30 is multiplying y. The inverse of multiplying is dividing. You show division with a fraction bar in algebra. And so when I rewrite this, 30 does not go into 47 evenly, and they have no factors in common, so this expression does not reduce. You could write this as a decimal, but I'm just going to go ahead and leave it as a fraction. For me, I prefer one less step, and writing it as a fraction is a little bit faster. The next 3 examples are actually problems for you to try. So I'm going to ask you to pause this video and try the problems. If you're really nervous, maybe just try number 5 first and see how you do. Number 4 is then probably the next one to try, and then number 6 is the one that's got the most steps for most students. After you've tried them, go ahead and restart this video and you can look and see how you did. And then you could pause here in order to get any clarification. I'm not going to go over these out loud since they were ones for you to try, but the solutions are on the screen for you. So we have 3 more problems to finish up for examples, and then there's a couple more for you to try on your own. So for examples 7 through 9, I'm going to go through my steps. There is no distributive property. The only like terms we have are on different sides of the equation, so I cannot combine them. Instead, I'm going to eliminate one of these variable terms. I'm going to eliminate the smaller one. 4 is smaller than 6. So I'm going to take it away. Notice that it started off with a positive 4. I'm going to cancel it through addition and subtraction only when you are dealing with variables that are on both sides and you're trying to eliminate an entire term. I'm going to rewrite this as 2x plus 8 equals negative 24. Next, I will eliminate any addition or subtraction. So 2x is equal to negative 32. And last, I will undo any multiplication or addition. I'm sorry, multiplication or division. Talking is hard today. And then these do divide out evenly, and I get negative 16. Don't feel anxious if you don't always get an integer or a whole number answer. It's quite common. All right, number 3, I'm going to start this one with the distributive property. Be careful with this negative. This negative is attached to the 3. So when I am distributing, I'm multiplying by a negative 3. And when I distribute to the second term, a negative times a negative makes this a positive 6. I'm going to circle that plus sign to draw your attention to the sign change that happened there. All right, next step would be to combine any like terms that are on the same side. I don't have that. And so I'll go to step 3, which is to deal with the variables that are on 2 different sides, on both sides. And what I've got on this particular problem is the negative 12d and the 7d. And I'm going to eliminate the smaller set, and a negative is always smaller than a positive. You could have chosen to eliminate the 7d. Some kids like to do that because it keeps the variable on the left-hand side. So I'm going to have now the variable on the right-hand side. That's totally okay. It might feel uncomfortable for you, and if you'd like, you could just rewrite this equation and flip-flop it, but I'm going to keep it this way. I will subtract 31 to cancel the addition, and rewrite this as negative 25 equals negative 5d, and then divide. When you divide, you have to divide by the exact same number that is multiplying D. The way you cancel multiplying by -5 is you divide by -5. There is no sign change when you're canceling that -5. Sometimes people try to divide by +5. You're canceling multiplying with division of the exact same number. Now, over on this side, when you divide, a negative divided by a negative will convert back to a positive. Number 9 is our last example. I'm going to start with the distributive property. There's actually the distributive property more than one time here. I am going to notice that when I'm distributing here, I'm actually distributing a positive, which is kind of nice. And that makes my life a little bit easier because I don't have all of the sign changes that happens when you distribute a negative. All right, step 2 would be to combine like terms as long as they're on the same side. So this 5 and this 32 are like terms. They don't have a variable. They're just constants, so I can combine them together as a 37, and I'm going to rewrite my equation. Although 12y and 10y do have the same variable to the same power, because they're on different sides of the equation, they are not considered like terms. I'm going to cancel one of them. I choose to cancel the one that's smaller, and a negative is always smaller than a positive. And then I'll rewrite this. If you had wanted, you could have canceled the 10y. Instead, you would have gotten an equivalent equation. And now I'm going to subtract off 5 from both sides. Your goal is to isolate the variable. So you want to get rid of the addition or subtraction that's on the same side as the variable, even if that's on the right-hand side of the equation. And the last step would be to undo multiplying by 22, so I will divide by 22. Now 22 does not go into 32 evenly. However, they do both have a factor of 2 in common, so I'm going to reduce out that common factor, and my final answer is 16/11. The last 3 problems are ones for you to try. They kind of go in, well, I would guess probably number 11 is the hardest. So if you're feeling a little nervous about this, maybe you save number 11 for last. But pause this video and try the problems. After you've had a chance to try them, restart this video and you can compare the answers. So here are the solutions that you should have gotten when you did these problems on your own. And that is the end of our notes for topic 1. And so please do the topic 1 homework assignment in preparation for the next class.